I am Prabhavati. Today I will walk you through data engineering, what tech stack will be used, what data engineering is. I'll walk you through everything and what will be covered in this course. All the details I'll be providing in this. So let me share my screen. I hope you are all, I am audible to all of you. Okay. Now, what is data engineering? When we say data engineering, it always deals with data coming from various sources, integrating it into one system, and finally handing it over to analytics team or the data scientist team to build the future reports or to make some future decisions. So data engineering is all about integrating data from integrating data from various sources for building analytics reports or data models by data scientists. So data engineers acts as a bridge between the data analytics and data science team. Uh, whatever they require, whatever the analytics teams require or the data scientists require, data engineering will be the point of contact because all the data, whatever they need, is provided by these data engineering people. So what it does, so in real time, we can take any kind of projects, either it might be banking, investing, insurance, anything, any domain, financial domain, insurance domain, whatever it is, we'll be using data engineering. So in every domain, we'll have a scope of the data. Like they might be sending data from various sources like APIs, SFTPs, or some of the times we'll be directly getting files through emails. So whatever the source it is, we need to extract the data. So extract the data. Uh, After extracting, the business people might not need it exactly what is there in the extract. I mean, what is there in the raw source. They don't need raw data. They need some modified data. So all these modifications, we'll be doing it. So that process is called extract. We'll be doing some modifications on top of that data. That process is called transform. And later, we'll be loading it into one of the data warehouses or the database. So analytics team or the data scientist, these people will be consuming data from one of the databases or the data warehouse. All the data from various sources, it should be in one system, one place. It should be in one place so that it would be easy for them to analyze. So data engineering involves building ETL pipelines. When I say ETL pipelines, it stands for extract, transform, and load. Extract, transform, and load. Extracting data from various sources, transform the data using based on the business requirements, and then load it into one of the data warehouses or the database. So this ETL process, it looks like simple extracting, transforming, and loading, but we have to use various technologies to uh, to build this pipeline. We call this as ETL pipelines. So for building these ETL pipelines, we use various technologies for each of these activities. So for extraction purpose, we use Python. Python used for data extraction. I'll slowly introduce what tools will be used in each of these activities and what are the things we need to know in each of these. So first we need to use Python used for data extraction. Not only for data extraction, there are other activities which we can do with Python as well. But initially we use Python for extraction. Python has a big package called Pandas. Pandas is used for data transformation. When I say data transformation from the source, I mean, whatever the source it is from API or the emails or anything, whatever the source it is, we will be getting some data. On top of that, there might be some empty rows or the date columns getting some string columns or the number columns getting some unexpected data. All these cleaning activities should be done on the extracted data or the raw data. that activities are handled with the Python pandas. We do transformations here. So accordingly, the data type will be converted, date column will be transformed to date, number will be transformed to number. And sometimes there are currency columns, like there might be some amount columns in which we'll be receiving dollars, comma symbols, some special characters are getting in that. But while loading into data warehouse, all of that is not uh, supported. So we should remove all of them. If it is a number column, it should have strictly numbers, no spaces, commas, or any special symbols are not allowed. So before loading into the data warehouse, we need to do these transformations. Transformation involves cleaning of data, and then uh, transforming data types, cleaning of data and transforming data types. It involves a lot of activities depending on our project or our data. So basically, data cleaning activities will take place in the pandas. And then extraction is done. So we need to keep this data, extracted data in some place. So we should have some storage location. For storage or all the activities, we should be good with one of the cloud technologies. So the cloud technologies we have nowadays is AWS, Azure. Azure is a Microsoft service, and then Google Cloud, GCP. So we should be familiar with one of these services. So in all of these three cloud technologies, there are various services and number of hundreds of services available, but we don't need all of them. We just need in any of these technologies, you can select anything, that is fine. In all of these technologies, we should be good at storage. Storage, when I say storage, all the data extracted from the source, it should be stored in some place. It should not be stored in our local system because it should be accessible by all our project members, so that it should be in some cloud storage. And then uh, storage, and then I'm saying we have to load that data into one of the data warehouses or the database. So we can say that database or data warehouse. There is a small difference between database and data warehouse. I will tell you during the course. So we should be good at these technologies. In the cloud, we don't need to know all of the services. We just need to know the few services. Only two services are required for us here. So one is storage service and the other is a database or data warehouse. So storage. In our course, we'll be covering Azure. Azure is our cloud which we are using in our course. So in Azure, for storage, there is a blob storage. We'll be covering blob storage. And there is one more storage, advanced storage like Azure Data Lake storage. So for storage purpose, I'll be covering these things. And for data warehouse, we'll be using data warehouse hosted on a cloud, not specific to this AWS. There is a data warehouse called Snowflake, which is hosted on any of the clouds. It can be hosted on any of the clouds. It is just a software, just like a Facebook account. We can create an account and use it directly. It is as simple as that. So we'll be using this Snowflake account for the database or data warehouse. So all our data, extracted data and then transformed. After the transformation, we'll be loading that data to data warehouse. So this is the place where all our data resides in before the analytics team or the data science team further uses. So analytics team or the data scientist will use data available in the Snowflake. So they have some requirement. Let us say the analytics team or the data science team has some requirement. So they will come to us, say, if we need this data, please build a pipeline. So based on their requirement, we'll be building the pipelines. So next, coming to the cloud, I'll be covering this storage is ADLS and data warehouse is Snowflake. And then ETL process, we are doing each step with a different technologies. But at the end of the day, we have to integrate all of them. All of them should be integrated. Like first extract has to happen, post the transform has to happen, and later load has to happen. All these activities should happen one after the other. So every day it should happen. It is a daily process. So there will not be a person who will be sitting and triggering each of these jobs. So there should be some automated process. So for automation or the ETL tools. First, let us say ETL tools. ETL can be built with Azure Data Factory. Azure Data Factory. So ETL pipelines are built with Azure Data Factory in our course, but in general, we'll be using Python, SQL. We'll be writing everything with Python because Python is an open source language which can be integrated with all the technologies. When I say cloud storage integration, storage can be integrated with Python and database can be connected with Python. You can name anything. It will be doable with Python. We can do anything with Python. So we can build ETL pipelines in any number of ways, but in our course, we'll be covering the Azure Data Factory. And in general, pipelines will be built with Python and Airflow. Airflow, we can call it as a scheduler tool. For scheduling the jobs, we might use cron expressions. Cron expressions are just like we have to define an expression so that that would say at what time of the day or at what day of the week it should run, the job should run. So we might use either cron expressions or Airflow or ADF. ADF is the Azure Data Factory. In Azure also, we'll schedule the jobs accordingly as per requirement. So for scheduling the jobs, we use this either cron expressions or Airflow or ADF. These are like automation tools which can trigger the jobs every day at the scheduled time. There will be no person sitting and running these pipelines. It is all automated process. It has to run every day. So now we have completed what technologies we use in our course. So data engineering, when I say in the real-time world, our daily routine involves daily routine. So what we do when we join as a data engineer in an organization. So the daily routine involves building ETL pipelines, and then Data ingestion. Data ingestion is nothing but extracting the data from various sources, transform it, and loading into a data warehouse. So data ingestion, and then I told that these all pipelines are automated, so they will run every day or every week as per the requirement, as an when we have scheduled. It depends on that. So, but we need to make sure that the pipelines are running smoothly. At the end of the day, there will be some reports for the analytics team or the data scientist team waiting for our data. So we need to make sure that our pipelines runs smoothly. So for that, we have to do monitoring or the production support. We have to monitor the pipelines. Production support for ETL pipelines. So these pipelines should run smoothly without any errors. If there is any error, then at the end of the day, the reports will be broken. So this is one of the job. There will be roles explicitly only for production support. It depends on the organization, whether there is a combination of development as well as support, or they are looking only for the support roles. It depends on the organization. So, and our work also involves data analysis. So we are ingesting data from various sources. Sometimes it is like the jobs will fail in between and the source and the target will not be in sync. When I say source is from different uh, places where the data is coming. And the target is Snowflake. Snowflake is our target data warehouse. So at the end of the day, the source might not be matching with the target. So we need to investigate why there is a data discrepancy between the source and the target, or they will provide various sources or the various numbers why the data is not matching between any two tables like that. So data analysis in case of data discrepancy. So these are our daily jobs. More or less in any organization, in any kind of data engineering projects, these are the daily activities. So if we know Python and SQL, I forgot to tell you one thing. With Python, we are writing extract and transform and loading into the Snowflake, which is the target data warehouse. So the data is in Snowflake. Now we have to use that data, do analysis, write queries, ingest the data. All these will be done with SQL. SQL is the most important thing in data engineering. Most important, I can say. 60% of the work will be able to do only with SQL. In our daily work, this extract, this Python thing, everything, this is only required in the initial phase of the project. But once the project is all set up, on a daily basis, we have to work mostly on SQL. So most important, 60 to 70% of our work is with SQL on a daily basis. So if you know SQL, we can use it on any of the databases or data warehouse. Either it is Snowflake. Snowflake is hosted on all the cloud platforms, but I will explain a little bit on AWS as well. So AWS storage services S3. In AWS supports S3 as the storage service, and then data warehouse. Data warehouse in AWS is, we call it as Redshift. Redshift is only specific to AWS. But Snowflake, whereas Snowflake, it can be hosted on, sorry, it can be hosted on any cloud. But coming to AWS, we have only Redshift as a data warehouse. And similarly, if you want to use the cloud data warehouse in Azure, there is a data warehouse called Synapse. Synapse. So we will not be covering this Synapse and Redshift, but I'm just giving an idea. So if you know any one of the data warehouses, rest other data warehouses will be similar. More or less, it will be similar. So in each organization, one organization might be using Snowflake, other will be using Redshift, another will be using Synapse. It is more all of them are like similar. If you know one thing, you will be able to work with the rest of the things. So in our course, I'll be covering data warehouse as a Snowflake and the storage, blob storage and ADLS. I'll be covering a little bit on S3 as well. S3 is a storage service, just like the Azure blob storage. It is like all of you know Google Cloud Storage where we can store photos, Google Drive, everything. It is just like that. S3 or the blob storage is equivalent to that Google Cloud Storage. So it also what type of cloud is used. It also depends on the organization, but nowadays most of them are using Azure and a few organizations are also using AWS. AWS and Azure are the most frequently used data warehouses nowadays. Uh, these are our daily work. So coming to the job opportunities. So if you know Python and SQL, you will be able to crack the interviews. Python plus SQL. So most of the interview questions will be around Python and SQL and little bit on this cloud and automation. If you know Python and SQL, you'll be able to crack most of the interviews. And then if you know Snowflake, only with Snowflake, there are roles only with Snowflake as a Snowflake developer or Snowflake engineer roles. So to become a data engineer, we should be good at one programming language. So programming language here we are using Python and SQL is mandatory SQL. If you know SQL, you should be able to work with any of the database or any of the data warehouse. With Oracle, you can if you know SQL, you will be able to work with Oracle, MySQL, Redshift, Snowflake, Synapse, anything. You can name anything. You will be able to write SQL queries. Whatever the database it is, we'll be writing SQL queries inside that. So if you are very good at SQL, you don't face any difficulties in daily work. And then you should be good at one of the cloud. Here we'll be covering AWS. Sorry, not AWS, Azure. Sorry. And for building ETL pipelines, we'll be using ADF and databases Snowflake. These things will be covering in our course. It will take around 2 to 2.5 months to cover these contents. And each technology will be dealt by different faculty. I'll be teaching Python, and other technologies will be dealt by some other persons. So till now, do you have any questions? Okay, if you don't have any questions, this is what we are going to cover. And after the end of the course, we'll be explaining the project. I'll be explaining one of the real-time projects. We'll not build the end-to-end pipelines, but I will be explaining the project, how these different tools are used, what the daily work involves, how it is. I will explain that project explanation. And for preparing the interviews, you should be good at Python and SQL. If you are good at Python and SQL, you will be able to crack interviews. But other technologies like data warehouse, cloud, it all depends on the organization to organization. It might differ. What technologies they use, it might differ. But Python and SQL are mandatory and common in anywhere you go anywhere. Yeah, this is a high level of what we do in the data engineering. Let me know if you have any questions. Okay, if you don't have any questions, this is it for the demo.